Hello everyone, I am Dhiraj of Engineering Physics 3rd year at IIT Roorkee, and today we are going to discuss about the experimental analysis of the study of Ldr characteristics. Proceeding with the defining the objective of this experiment, we are going to see the apparatus required for performing this experiment. After that, we are going to discuss the working principle and the theory of LDR. Then at last we're going to see some of the application of LDR which we can see in our day-to-day life. The objective of this experiment is to study the response of light-dependent resistance utilizing the provided experimental setup by systematically varying the intensity of incident light at the given voltage. The apparatus required for performing this experiment is a DC regulated power supply and connecting wires which are used to connect the voltmeter and ammeter with the LDR, and then we need a light source and a measuring. So a light dependent resistor or a photoresistor is a light controlled variable resistor. Its resistance changes with the light intensity that falls on it. So these are mainly made up of semiconducting materials having high resistance. For example, cadmium sulfide and cadmium selenide. So this resistance range of the semiconducting materials and the sensitivity of this photoresistor can substantially differ among dissimilar devices. For example, the cadmium sulfide typically exhibit high resistance in the range of megaohms to gigaohms. On the other hand, this cadmium selenide typically exhibits higher conductivity compared to cadmium sulfide with resistance values in the range of kiloohms to 10 of kiloohms. And here is the picture of the this cadmium sulfide um, light dependent resistors, which basically consist of two metal film contacts and a wavy track of cadmium sulfide. So let's discuss about the working of LDR. So basically it works on the principle of photoconductivity. So photoconductivity is an optical phenomenon in which the material conductivity is increased when light is absorbed by the material. When light falls on the like for we can say photon falls on the device, the electron in the valence band of semiconductor are excited to conduction band. These photons in the incident light should have greater energy than the band gap of the semiconductor to make the electron jumps from the valence band to conduction band. Hence, when light having enough energy falls on the device, more and more electrons are able to get excited to the conduction band, which results in large number of charge carriers. The result of this process is uh, more and more so that current start lowering through the device when the circuit is closed, and hence it is said that the resistance of this device has been decreased. Now I'm going to show you the procedure of this experiment. So let's start with this. So here in this apparatus, as you can see that we have fixed the voltage across the circuit, and we are basically measuring the corresponding current by varying the distance between light source and the LDR. As you can see here that on increasing this distance between the light source and the LDR, the current starts decreasing, and further when we decrease this distance by moving this light source towards the LDR, then the current of this ammeter starts increasing as well. So using this we can find the relation between the resistance and distance between the light source and the LDR, and using that distance we can find the intensity as well. So these are the observations that we derive from this experiment. So here we fix the voltage at 2 volts, and then we vary the distance between LDR and the light source, and then we note down the current corresponding to that given distance, and then using Ohm's law we can find the resistance of this LDR. So this is the plot between resistance and the distance between the light source and the LDR, and from this plot we can conclude that there is non-linear relationship between resistance and the light intensity, which maybe arise because of the some semiconductor properties like band gap energies, material properties, hysteresis, etc. Here are some of the applications of LDR. So LDR is used in light sensing system for automatic control of lighting fixtures, street lighting and outdoor scenes. So other applications are it is employed in photometry and photo detection for measuring the light intensity and the exposure level. It is also used in automotive sector for automatic headlight dimming, interior lighting and adaptive brightness adjustment. And the most important, it is used in security purpose to integrate into security and surveillance system for detecting changes in ambient light. So at last, I want to conclude that the study of characteristics of LDR has provided valuable insight into its behavior in response to variable light conditions. Through experimental investigation, we observe that the resistance of LDR decreases as intensity of incident light increases, demonstrating its light sensitive nature. And on analyzing the curve, we can find that there is a non-linear relationship between the resistance of LDR and the light intensity of the instant beam. And moving further, we could also research the effect of temperature, wavelength, and spectral distribution of LDR on distribution of light on LDR behavior to enhancing reliability and application across varying contexts. This is all from my side. Thank